Now it's your turn to draw the graph of a quadratic function. You'll do this by determining if the parabola points up or down, finding the vertex, creating a table of values around that, and then finally sketching the function. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this example, we're given the function g, where g of x equals negative 2x squared minus 3, and our eventual goal is to sketch the graph of this quadratic function. To start, we'll determine if the parabola opens upward or downward. We can see, based on this formula, that the coefficient on x squared is negative 2, and so we know that this parabola will open downward, as that leading coefficient is negative. So we can state that it's downward as a, the leading coefficient, is negative 2. To find the vertex, we'll use x equals the opposite of b over 2a. And if we look at this, we have g of x equals negative 2x squared minus 3. So a, the leading coefficient, is negative 2, and c, the constant, is negative 3. But b is actually 0 here, since we don't have a term with a coefficient on x. So x will be the opposite of 0 over 2 times negative 2. And so we just get 0 over 4, which is of course the number 0. To find the output for this vertex, or the y value, we'll evaluate the function g when x is 0. So to find y, or that output, we'll calculate g of 0, and we do that by replacing x with 0 in that expression negative 2x squared minus 3. So g of 0 will then equal negative 2 times 0 squared minus 3. And that just simplifies to negative 3. So we know now that our vertex is the point 0, negative 3. Next, we'll create a table of values for this function, and we're going to center it around the vertex, since in this case that'll be our highest point, so we want points around there. So creating a table, create a table with x values and y values. And I'm also going to list the points in this table, just so that when I go to graph it, I already have that organized. So x values, and then negative 2x squared minus 3, those are the outputs. And then I will put ordered pairs also in my table. So I'll have x, y pairs from those inputs and outputs. So our vertex is 0, negative 3, so we're going to center this table at 0, and so I'll pick a couple x values on each side of that. I'll do negative 1, negative 2, and negative 3 going up in that table, and then down from 0 I'll go 1, 2, and 3. Another key thing to note is that I'll have symmetry around x equals 0. The line x equals 0 is actually my axis of symmetry, so I won't have to do all of these calculations if I use that symmetry. To start, let's evaluate negative 2x minus 3 when x is negative 3. And we will then just replace x with a negative 3, so I'll have negative 2 times the number negative 3 squared minus 3. And remember that when we square a negative, it becomes positive, so this is negative 2 times 9, or negative 18, minus 3, and so we'll get negative 21. Going to where x is negative 2, we're going to have negative 2 times the number negative 2 squared minus 3, and so that will equal negative 2 times a positive 4, or negative 8, and then we're subtracting 3, so we'll get negative 11. Continuing on, we'll evaluate this expression negative 2x squared minus 3 when x is negative 1, so I'll have negative 2 times the number negative 1 squared minus 3, and that becomes negative 2 times a positive 1, or just negative 2 minus 3, so we get negative 5. At 0, we already evaluated this in finding the vertex, and we knew that that output was negative 3. So let's stop and write these points down. At negative 3, our output was negative 21, so that's the point negative 3, comma negative 21. At negative 2, our output was negative 11, so we have negative 2, negative 11. At negative 1, our output was negative 5, so we have negative 1, negative 5 as the point. And then we have the point 0, negative 3, which we know to be the vertex. And now, I'll continue evaluating this for when x is 1, but at this point I could use symmetry to determine all the rest of these function values and points. So let's do one of them. We'll do negative 2 times 1 squared minus 3, and that's going to be negative 2 minus 3, which is of course negative 5. And at this point I can see that the function values are going to mirror the ones on the other side of x equals 0. So I'll have 1, negative 5, and I'll use that symmetry then instead of evaluating at 2 and 3. So my next function value will be negative 11, and the next one will be negative 21. The points then will be 2, negative 11, and 3, negative 21. And so I'm ready to graph this function now, and I'm just going to stick with these middle 5 points. I'm going to leave those larger ones, those two end ones, or outermost points off. So coming over to my grid, I have a 12 by 12 grid here, and I need to make sure that I fit in y values between negative 11 and 11, and, oh no, negative 11 and negative 3 is actually the largest. And x values, I'm just going between negative 2 and 2. So there's a couple different ways I could scale this, but I'll label these x and y axes, and then I'm going to scale the x-axis so that each tick mark, or each 2 tick marks is 1 unit. So I'll write a 3 at where there's 6 tick marks, and a 6 where there's 12, and so each of those 2 tick marks is representing 1 unit then. And I'll do the same thing but with negative 3 and negative 6. For the y-axis, I'm just going to make each tick mark worth 1 unit, so I'll mark off 6 and 12, and then I'll mark off negative 6 and negative 12. Now I'm ready to plot these points, so I'll plot the point negative 2, negative 11, and I'll make sure and keep track of where negative 2 is on this x-axis. So I see negative 2, negative 11, I'll plot that point, and then I'll have negative 1, negative 5, I'll plot that point. I have 0, negative 3, I'll plot that point, and now I'm going to see symmetry on the other side. I'll have 1, negative 5, and 2, negative 11. Now that I have these key points, I'll connect them with a smooth curve. And on the ends of that smooth curve, I'll make sure that I put arrows to show that it continues. And that's the graph of this quadratic function.